So what comes before learning system Verilog? So before this system Verilog, we need to learn certain verification fundamentals. Verification fundamentals. We'll be going through all the constructs that were there in system Verilog, but in the first hand, we should understand why we are using all these constructs to make the thing simpler. For now, I am saying it is in the part of verification. So let's understand some of these verification fundamentals. So in verification guidelines, we should plan how to verify a particular design. Let's say you are given a task of building an house. So where you will start with? Will you start with building kitchen? Will you start with building a corridor, or will you start with building a bathroom? It's not the case. Like, you will first approach the owner and you will know how much budget he is having, and you will ask him in what way he wants to see the building, all those things. After having certain plan or certain blueprint, then only you start building the house. Similarly, before verifying a design, you should plan how to verify a particular design. We will be seeing what are all the guidelines and coding styles for a design and constructing the test bench. What basically these test benches will be seeing in little while. So as a verification engineer, we should see that bugs are good. Like, if I am a verification engineer, I should say, if I am finding some bug, I should feel happy that I am going to like notice this bug. Because when the design goes into tape out, like fabrication part, if you found certain bug, then like it will cost up to 10x more than what it costs when we resolve this particular bug in the design phase itself. What makes the system Verilog stands out? When I am saying system Verilog, so we are obviously not using Verilog, we are moving to some other language. So there should be some certain use cases or certain features that are extra on top of Verilog. So in system Verilog, we have constrained random stimulus generation. What this means, we'll be seeing in detail in our course. So for whatever things we need to verify, we need to generate some stimulus. So that stimulus will interact with the design under test, and it will get some response. Based on that response, we will say whether it is performing as expected or not. So the other one is functional coverage. How much coverage were we able to extract out of our design? Based on this functional coverage, we can analyze. So another important or interesting thing that system Verilog is having is object oriented programming. This is one of the important constructs in the system Verilog. And one more thing is transaction level modeling, and multi-threading and inter-process communication is also another important feature. Like, because there should be more interaction between different modules, we are not going to work on a single block or single module. We are going to interact on multiple blocks. Let's say we work on different protocols. A protocol might interact with another block or another module, then it needs some inter-process communication and all those stuff. We'll be seeing all these things in little while. So when we are saying that verification is only to find bugs, it is absolutely not. Because what happens typically is, when we have a specification document, when we have a specification, we have certain design engineer designs based on the specification. Typically this is written in RTL, and this design needs to be verified. This need to be verified by the verification engineer, whether it is expected, like it is doing the things that actually we expect. Let's say we have a DVD player, so whether it is giving out the music that we are intended to get, or let's say we have a protocol, sender receiver protocol, whether the acknowledgement is happening whenever it is intended to do. All these things were verified by the verification engineer, and he should see whether it is aligned with the specification or not. if it is not aligned with the specification, then we can say there are certain inconsistencies in the specification. Like it's consider all the corner cases that designer might not think about. Like sometimes designer might miss out some things which are there in the specification, where an verification engineer was able to notify it, and he can brings to the mind of designer as well.